Here we're going to look at example 3 from section 3.3, where we'll use polynomial identities to factor and simplify. So in the top right here, I've already written out our identities, so some of the polynomial identities that we should be familiar with, and we're going to apply those in parts A and B. So how can you use polynomial identities to factor polynomials and simplify numerical expressions? So let's look at part A. We have 9m to the fourth minus 25n squared. First thing that I would notice here is that this is the difference, and 9 and 25 are both perfect squares. So this is going to be the difference of squares. Right, and that's the identity I'm going to use. And that one, the difference of squares, would be this one here. The a squared minus b squared equals a plus b times a plus b. So I'm going to write that out. What we always have to make sure of is that the term is in the expression a squared minus b squared. So this 9m to the fourth minus 25n sixth actually needs some work. All right, the 9m is not our a value. What we need to look at is what term squared gives us 9m to the fourth. So what I'm going to do is 3 squared is 9, and then m squared, so let me write that a little larger. So we're going to look at what term squared gives us that 9m. So what squared is 9? Well, 3. And what squared is m to the fourth? That would be m squared. So my a value is going to be 3m squared. And I need to do the same thing for my b value. I need to ask myself what expression or what term squared is going to get me 25n to the sixth. So what squared is 25? Well, that's pretty easy. That's going to be 5. And then what squared is n to the sixth? Well, that would be n cubed or n to the third. Now that I know my a and b values, so this will be my a, I can plug those in, and this 5n cubed would be my b value, so I can plug that in. So this would be equal to 3m squared plus 5n cubed times 3m squared minus 5n cubed. Let's put one there to separate those. And this would be my expression multiplied out. Or sorry, factored out, not multiplied out, factored out, and then we simplified that. So part B, now we're looking at x cubed minus 216. Since I know we're dealing with polynomial identities here, I'm going to be pretty confident that 216 is a perfect cube. And in this case, this is the difference of cubes. So I'm going to want to use my formula, or my identity, sorry. A cubed minus b cubed is equal to a minus b times a squared plus ab plus b squared. And as before, I need to make sure that my expression is actually in a cubed minus b cubed form. So I have x cubed minus 216, and clearly that is not yet in a cubed minus b cubed form. The x cubed is good, all right? That could just be x cubed. However, the 216, I need to figure out what the cube root of 216 is. So what number to the third power gives me 216? Well, once you're familiar with cube roots, you'll realize that's 6. So 6 cubed would be 216. And now, once again, I have my a value that I can plug in, and I have my b value that I can plug in. The most common mistake with these problems is not using the correct a and b and not finding the actual cube root or the square root or whatever it happens to be. So do be careful with that a and b value. Now I can plug these in. So I get a minus b, which is x minus 6, times, I'm going to put everything I substitute in parentheses, x squared plus x times 6 plus 6 squared. So I'll simplify that as x minus 6, x squared plus 6x plus 36. And this would be my, using my polynomial identities, that's what I would work that problem out to be. Again, x minus 6 times x squared plus 6x plus 36. I know I say it a lot in my videos, but I cannot stress enough that you figure out what your a and b values are. The most common mistake, without question, on these problems is using the incorrect a and b values. For problem B, 216 is definitely not your b. You'll always need to have everything written in this form. All right, so for, in this case, difference of cubes, we need it to be a cubed minus b cubed. If it's not written in that form, we can't use whatever numbers that are there or terms that are there as our a and b. So do be careful with that, and if you are careful with that part, everything else should fall in place quite easily.